Hi there, folks. This is the review for the Unit 1 test, and I am the amazing Mr. Jansen, so here we go. If we look at these first couple, I want to decide if each relation is a function, and then I'm going to state the domain or range. So if we're deciding if something is a function, we basically just have to look through and see if there's any x values that are with different y values. So we're looking for repeated x values here, and as we look at these x values, we don't see any that are repeated for this first one. And that means that each of these x values has only one y value. If we don't see a second x value, well, then it automatically means that this thing's going to be a function. So this one is a function, so the answer is yes for that first question. Yes, it is a function. And now in terms of the domain and range, the domain, we just say the domain is going to be x such that, and then we're just going to list the x values here. And we always do least to greatest. And any values that would happen to be repeated, we just write them once. And that's it, okay? The range is very similar. We're going to do the same thing, so I'm going to say the range here, except this time it's y, so I say y such that. Again, I list the y values. I want to do it in order from least to greatest, so the -2, then the -1, then the 3, the 4, and the 7. And notice the 4 occurs twice, but we only list it once when we do our range, okay? In the next one, again, we look for repeated x values. We see if there's one x value with two different y values. And right here we see this 1 is repeated. And this 1 is with a positive 1 over here, but then it's with a 0 over here. So because that x value is two different y values, we're going to say that this one is not a function. So I'm going to say, no, this one is not a function. And now the domain and range. Again, I'm just going to list these. The domain is x such that. And I will list these in order, so it looks like the -2 is the smallest. Then the 1, then the 2, then the 4. Again, even though that 1 occurs twice, I only write it once. The range, I do the same thing except with respect to y, so y such that. I'm going to write down my y values. Looks like -7 is the smallest one, then -5, 0, 1, and 3. Okay? Number 3, when we have a graph, we're just going to do our vertical line test. So I take a vertical line and I drag it over my function. And for this thing to be a function, it's got to touch just one point at a time. If it touches 2 points at once, then it's no good. So right here we can see that it's touching 2 points at a time, which means there are two y values with each of those x values. So because it touches 2 points at once, we said this one is not a function. So the answer is no for this one, not a function. And then the domain and range. The domain, you just look left to right and say, all right, this is going to be x such that. Well, when I look to the left, this thing goes forever to the left because of those arrows, all right? And then to the right, it goes to about +6, so it looks like it's the furthest it goes to the right. So when I look left and right, it goes from 6 all the way down to -infinity. In other words, my x values are less than or equal to 6, so I just express that as an inequality. So the domain is that x is going to be less than or equal to 6, and that's it. And then in terms of the range, I do the same thing, except this time I'm looking up and down. If I grab this line and turn it the other way here, if I scan this thing up and down, it looks like it goes up forever and down forever, because keep in mind, these arrows, this thing is decreasing slightly, and it's going to keep decreasing slightly as it goes, and over here it's increasing slightly, and it's going to keep increasing slightly forever because of those arrows. So that means it goes up forever and it goes down forever, which means my y value is going to be y such that y is all real numbers. And I'm just going to use the symbol for all real numbers, which is a little r with a bar on it. Okay? Look at these next couple. We want to evaluate these. In function notation, remember whatever's inside the parentheses, that's what we want to plug in for x. So this first one is g of 2, which means I want to take my g function, which is this guy right here, and instead of an x for each of these spots, I'm just going to plug a 2 in. All right. So when you think about this, I like to think of these as blank spaces. This is like a negative x squared minus 2x plus 1. Okay, that's essentially what this thing is saying. But instead of x here, I've got a 2 in the parentheses, which means I'm going to plug a 2 in for each of these. And now I follow order of operations. This is like a -1 out front, so I have to square this thing first before I multiply. So 2 squared is 4, then times the -1 is a -4, minus 4 plus 1. And now I add these together, that's a -8 plus 1, which is a -7. All right, so I say g of 2 actually equals a -7. And the thing that's nice about function notation is I can see everything that I want, my input and my output, side by side. See, here's what I plugged in and here's what I got out. And that's what's neat about function notation. All right, that's it for this one. In the next one, I do the same thing. I want my f function this time. So my f function, I had a negative 2 times the absolute value of x plus 1, and then the plus 3. And since I have a negative 4 in the parentheses instead of an x, I plug in a negative 4 where x was. And now I just simplify. With absolute value, remember we do what's inside the absolute value first. So negative 4 plus 1 is a negative 3. And I should leave that as an absolute value for now. Sorry about that. And now from here, I actually take the absolute value, and keep in mind the operation that's happening here is multiplication. Absolute value act the same way the parentheses do, so when I have a number outside the absolute value, it's multiplication. And so what ends up happening here is I get negative 2 times a positive 3 when I take the absolute value, and then plus 3. So now I do a little bit of multiplying. Negative 2 times 3 is a negative 6. Plus 3 is going to give me a negative 3. All right, so f of negative 4 is a negative 3. Once again, I can see it, input and output, side by side. All right. If I look at the next one, I want to do h of negative 1, so now I'm using my h function. And the h function is a piecewise function, so I have to look down through this thing and decide where I would use an x value of negative 1. And that's defined by what's over here. These things on the other side of the comma basically tell me which x values are being used. In other words, I use this first function, the 3x minus 2, when I have x values that are less than or equal to 1. I use the second function, the 5, when x is greater than negative 1 but less than or equal to 4. And I use this last function when the x values are greater than 4. All right. So since I have an x value of negative 1 this time, it's telling me that I have to use this top function, okay, because it's defined right here. When I have an x value of negative 1, I use this top function. All right. So I'm going to plug it into this first function. That's going to be 3 times x minus 2, but instead of x, I'm going to plug in the negative 1, and now I just simplify. 3 times negative 1 is a negative 3, minus 2 is a negative 5. All right. Again, input and output, side by side. That's what's neat about function notation. If I look at the next one, I want h of 2 this time, so I look down through those intervals that were listed. And a positive 2 is going to be in this second category. It's greater than negative 1, but less than or equal to 4. And so I want to plug it into this second function right here. So I'm going to plug it into this guy, which is h of x equals 5. Well, h of x equals 5 is essentially saying y equals 5. So when I plug a 2 in there, this thing is still going to equal a 5. That's what a constant function or a horizontal line, the function of a horizontal line is. It's saying no matter what the x is, y equals 5. Okay? If I look at the next one, f of 0 this time, so this time I want to take my f function, which the f function was the negative 2 absolute value of x. I'm not going to write the x, plus 1, and then absolute value of 3. But instead of x, I want to plug in the 0, so I'm going to plug a 0 in where x was. And now I just simplify this thing. So again, I get negative 2, absolute value of 1. And just like before, that absolute value of 1 essentially becomes a 1. And it's multiplication that I have here. So now I'm just going to do a little bit of multiplying and a little bit of adding. So negative 2 times 1 is a negative 2. Plus 3 is a positive 1. So I put the positive 1 down, and that's it. So f of 0 is a positive 1. And I can see my input and my output side by side. Okay? The next one, h of 4. I got to go look at this piecewise function, say, okay, a value of 4. Well, that falls into this middle category again because that equal to condition. And once again, that's just y equals 5. So no matter what x is, my y value is going to be 5. So it gives me the ordered pair 4, 5, input and output. There it is. If I look at this next one, I'm doing a little bit of multiplication here, but I have to find h of 5 and then g of 1 first. So I'm going to do each of these separately. So I'm going to start with the h of 5. So when I do h of 5, it's telling me that I want to use, let's see, come back up here, and I look at greater than 4, so it's going to be this last function. So I'm going to be plugging into this last guy right here. So I go ahead and I plug that in. I say negative 2, and I'm plugging the 5 in for x. And then I'm also going to do the g of 1 function. I'm just going to separate these a little bit. So I'm going to do the g of 1 function. So the g function, once again, was the negative x squared minus 2 times x plus 1. but instead of x, I'm going to plug in the value of 1, so I'm plugging the 1 in here. And now I'm just going to simplify each of these. Scroll down a little bit. So this first one, I find out that h of 5 equals a negative 10. This next one, as I start to simplify this thing, here I'm going to, again, this is like a negative 1 out front. So when I do this, I have to do the 1 squared and then times the negative 1 is a negative 1 minus 2 plus 1. That's going to be a negative 3 plus 1, which is a negative 2. So I've got h of 5 and g of 1, and this problem was actually telling me to take h of 5, which was the negative 10, times g of 1, which is the negative 2. So I multiply those together and it gives me a 20, and that's it. All right. So it's just asking me to plug these things in and then do an operation with the numbers that I have left. Okay. The next one I'm going to do the same thing. Let me separate this out. So I'm going to do g of 0. So once again, my g of x function, if I scroll back up just a little bit, g of x was the negative x squared minus 2x plus 1. But instead of the x, I'm going to be plugging in the 0. So I plug a 0 in for each of these. And when I simplify that, I find out that g of 0 equals 1. But then I want to do the same thing with my f of 2 function, or my f of x function. So I'm doing f of 2. So I take my f of x function, which is the negative 2, times the absolute value of x plus 1, and then plus the 3. But instead of x, I'm plugging in the 2, so I plug the 2 in. And now once again, I simplify just like I have been. That's going to be a negative 2 times the absolute value of 3. Now I take the absolute value. This becomes multiplication. So that's going to give me a negative 6 plus 3. If I scroll down just a little bit here. And negative 6 plus 3 is just going to be a negative 3. So I find out that f of 2 equals a negative 3. But now this asks me to do g of 0, which is the 1, divided by the f of 2, which is negative 3. So when I do that, it gives me a negative 1/3. And that's it. So it's asking me to plug each of these things in, and then it asks me to do one extra operation, which shouldn't be a big deal. Okay? If I look at the next one, I want to graph this thing. I'm graphing, and this is in y equals mx plus b, so I see the slope and the y-intercept. Remember, we start with the y-intercept, so I'm going to start with the negative 5, and I plot my y-intercept, so I'm down here at negative 5. And then I use the slope. The slope right here is a positive 3, so I go up 3 over 1. And I keep doing that, up 3 over 1. And I can do that as many times as is needed to make this a little bit easier for me to draw a nice straight line. And that's it. If I look at the next one I could solve for y and rearrange this thing so that it's y equals mx plus b. But I'm just going to find the intercepts. If I were to scribble out this guy, put a 0 in for y, and solve for x, here I divide each side by 2 and I find out that x equals a negative 9. And then I do the same thing for y. If I plug a 0 in for x, scribble this guy out, and I solve for y, I'm going to find out that y equals 3. Well, those are my x and my y intercepts here. And one of these is easy. The y equals 3 is right here. But the x equals negative 9 is way back here somewhere. It actually spills over onto my other graph. But that's okay because it still gives me my slope. If I count over and then up, I can still see the slope here. The rise is 3 and the run is 9. So in other words, the slope here is 3 over 9, which is 1/3. And since I have the y-intercept, I can fill in all the values that are in between here to make this a little easier. If I have a slope of 1/3, it means I would go down 1 back 3, down 1 back 3. And we can see if I went down 1 back 3 again, I'd be back there at the negative 9. I'll get rid of it since it's all the way on the other graph. But then I can keep going the other direction if I need a couple extra points to plot. Okay. So again, just using the x and the y-intercept, using that cover-up method, that's the way to go on this one. All right. If I look at the next one, it's an absolute value. An absolute value is going to be the V shape. So I need a V here. So I'm going to do the vertex and then decide which way this is going to open. The vertex here is negative 2, 1. Remember, we always have to do the opposite of this guy because it's x minus h. So my vertex is negative 2, 1, which is right here. My a value is negative, so this thing is going to open down. And the a value is a 2, so I'm going to have a generalized slope of 2 in each direction, so I'll go down 2 over 1 or down 2 back 1. So I do a slope of 2 essentially in each direction, just make sure my v opens down. And that's it. In number 15, we have to find the equation line that's parallel to y equals negative x plus 1, but passes through point 2, 1. So for this one, whenever we're trying to find the equation of a line, the two things that I need are the slope and the y-intercept. So it tells me that I'm going to be parallel to this line. So I look at the slope of this line, and this line has a slope of -1. And I know the parallel lines all have the same slope. So my line is also going to have a slope of -1. And now I just need to find the y-intercept. So I use a fresh y equals mx plus b. And I plug in what I know. I know the -1 is my m. B is the thing I'm trying to find. So really I just need an x and a y value. And that's why we're given this ordered pair over here. This is my x and my y. So I plug those in for x and y. So I plug the 2 in for x. I plug the 1 in for y. And now I'm just solving this thing for b. We're going to add the 2 to each side. So find out that b equals 3. And now I'm not quite done yet. I actually have to write the equation of my line. So let me write that over here. It's y equals a -x plus 3. And that's it. If I look at number 16, essentially the same thing, except how I find the slope is just a little bit different, but I still need the slope and the y-intercept. This time I'm told that I'm perpendicular to a line, so I'm going to be perpendicular. Well, this line has a slope of 2/3. Perpendicular lines, the slopes are opposite reciprocals, so instead of a positive 2/3, I'm going to do a -3/2. And now I do the same thing, a fresh y equals mx plus b, and I plug in what I know. I know the slope. B is the thing I'm trying to solve for, so I just need an x and a y value, and again, that's why I'm given this ordered pair right here. So I plug the 4 in and the -2 in, and I just need to solve. That gives me a -2 equals, this is going to be a -6 plus b, and then I've got to add the 6 to each side. So I find out that b equals a 4. And once again, I need to write this equation. So it's y equals a -3/2 x plus 4. That's it. Number 17, once again, I need two things, the slope and the y-intercept. This time I'm given 2 points, so to find the slope, I'm going to do change in y over change in x. So I look at the y values. Y was a 2, now it's a -5. Y has gone down 7 units, so I put down a -7. My x value was a -1, now it's a +3. It's gone up 4 units, so I put down a +4. And now once again I use a fresh y equals mx plus b. And I plug in what I know. I know the slope. I'm trying to solve for b, so I'm going to plug in an x and a y value. And I can choose either one of these. I'm going to use the first one because it looks a little simpler. So the -1 here and the 2 here. So this gives me a 2 equals 7/4 plus b. And now from here you can subtract the 7/4 from each side, and if you're comfortable doing that, that's fine. Many of you are probably going to be a little bit scared of this fraction, so to get rid of fractions I'm going to multiply each side by the common denominator. I'm going to multiply each side by 4. And over here I'm going to have to distribute. So what I do is I get 8 equals 7 plus 4b, and now it should be pretty simple to solve. Okay, so now I'm going to subtract the 7 from each side. Bring that guy over here, so I have 4b equals the 1, and then I divide each side by the 4. So I find out the b equals 1/4. And once again, I still have to write the equation of this thing, so it's y equals, that's going to be a -7/4 x plus 1/4, and that's it. Okay. For this one, I need to draw a scatter plot, draw a line of best fit, and then do a prediction equation, and then predict the value of 50. For the equation, I'll be able to use a linear regression, and I'll show that in a moment. But the first thing we need to do is we need to label this thing. I'm going to put age down here, and I'm going to put wisdom over here. And then I just need to scale this thing, and I'm going to go ahead and fill that out. So I've gone ahead and scaled each of these axes just to try to use as much of the graph as I can. And your scale might be a little bit different than mine, but there it is. And then I'm just going to plot each of these ordered pairs. Keep in mind this is my x and this is my y. So the first ordered pair, 15, 16. Then the next ordered pair, and I'm just going to plot each of these. So I've just gone ahead and slapped those down real quickly. Most of you should be able to do that on your own. But the reason I'm drawing this scatter plot and the reason I'm looking for certain things here is I want to know if there's any outliers, things like that. And so as I look at each of these values, it doesn't look like any outliers. It looks like I'm going to have a pretty good prediction equation that can be drawn through these. So I can draw a line of best fit through really any two of these lines. But for the prediction equation, I'm going to use the graphing calculator. So let me pull that up. And for this one, since there were no outliers, I'm going to go to Stat, and I'm just going to put all these values in. The very first thing there is Edit, so I click Enter. And I'm basically going to take this horizontal table and I'm going to plug it in vertically. So I plug in the 15, the 20, and notice I don't punch in the value of 50 because there's no y value that goes with it. So I just punch in the values that have x and y. And then I've got to punch in the y values that go with each of those. But I'm basically just taking this data and putting it into the calculator, and then my calculator is going to do all the work here. Okay, so now I've got all these ordered pairs punched in. I go to Stat, over to Calculate. Now that I've punched in the values, I go down to number 4, which is Linear Regression. I hit Enter, and you'll have two options here, either this, where you just hit Enter again, or you'll have to scroll down to Calculate and hit Enter. So I hit Enter, and basically it tells me that y equals ax plus b, and it gives me the a value and the b value. In other words, it's giving me the slope and the y-intercept. So it looks like I've got y equals 1.66x minus 9.7. So this is my prediction equation, 9.7, sorry. Right from the calculator, that's my prediction equation, but now I want to use it to predict this value at 50. So I've got to plug a 50 in for x right here. So let me pull my calculator back up, and I do the 1.66 times 50, and then minus the 9.7. And it gives me a value of 73.3 here, okay? And that's the prediction that I'm going to make right here, is 73.3 Smarties. Okay? In the next one, I want to graph this thing. The linear portion of this is y equals mx plus b. So it's got a y-intercept of 2, and it looks like a slope of 1, so I go up 1 over 1. Since this is an inequality, I have to decide if this is going to be a solid line or a dotted line. Since there's no equal to condition, I know that this one's going to be a dotted line, so I'm putting a dotted line down here. And then I have to shade one side or the other. Since the y value is greater than this line, I'm going to shade above the line. And the easiest way to test that is to plug in a point, and I can plug in the point 0, 0. If I happen to do a test point here and plug in the point 0, 0, I would get 0 is greater than 2, which of course is a false statement, and that's why I shade the other side of the line using my sweet crayons. Alright, if I look at the next one, I'm going to graph this one just like I would any other line. If I was pretending for a moment that this was an equal sign, if I scribbled this guy out and solved for y, that's going to give me the y-intercept, and the y-intercept here would be a -2. And then I could do the same thing with x. I scribble out the y, plug a 0 in for y, and I could solve for x and find out that that's a +4. And now I just need to remind myself that this is an inequality, and I have to draw a dotted line here because there's no equal to condition. And I can actually put in a couple extra points here if it makes it a little bit easier for me to graph. I can even see the slope happening here. But I use a dotted line because there's no equal to condition. And now for this one, I absolutely want to use a test point because it's not in that standard format or in my slope-intercept format. So I plug in 0, 0. When I plug a 0 in over here, I get a 0. When I plug a 0 in for x and y, I get 0 is less than a -4, which is a false statement. And so since I get a false statement, I'm going to shade the other side of the line. I'm going to use my sweet green crayon again. So I shade down here because I got a false statement, so I shade the other side of the line. Okay? On the next one, I've got absolute value, so I'm doing the absolute value this time. Whenever we're doing absolute value, you always want to start by identifying the vertex. Again, remember that in vertex form, this is x minus h, and this is a plus k. So I always have to do like the opposite of that x value, and then take the y value just as it is. So this one, the vertex is 2, -1. So I go to 2, -1. It's right here. The a value is positive, so this one's going to open up, and it's going to have a slope of 1/2. And I'm going to do that essentially in each direction. And this one, because there's an equal to condition, I'm going to use a solid line for this one, because there's an equal to condition, and again, this is absolute value, so it's going to be a V. And now I just need to decide if I'm going to shade inside the line or inside the V or outside the V. And once again, the best thing to do is to choose a test point. Now this time I can't use 0, 0 because it's on the line, so I'm just going to choose another point, something like maybe 1, 1 or something like that. Or the nicest, probably the best thing to do is something like this guy, 0, 1, because it's on one of the axes. So if I plug in 0, 1, I'm plugging a 0 in for x and a 1 in for y. Over here, when I plug a 0 in for x, that gives me a -2 inside here, which the absolute value of that is 2, times 1/2 is a 1, minus 1 is actually a 0. So when I plug that in, I get this statement that 1 is less than or equal to 0, which is false. So I'm going to shade the other side of this absolute value function. Okay? This absolute value equation. All right, so again, anytime we have absolute value, there's going to be an element of shading, and you're going to have to decide whether it's a solid line or a dotted line. When I look at number 22, the first thing I do is set up my intervals here. When I look down through these values that are listed over here, when I plot these intervals, I see values of -1 and of +4. So I'm going to put some vertical dotted lines, one at -1 and another at +4. And I'm just setting up these boundary lines so I can graph these things. And basically this first function right here, the y equals 3x minus 2, I only want to graph that when x is less than or equal to -1. In other words, I want to graph that in this first section. So I would think about where these points are. It would have a y-intercept of -2 would be right here. And then I would go up 3 over 1 or down 3 back 1. And on this line itself, because there's an equal to condition, I'm going to use a closed dot, and I keep going. And if I were to graph this entire line, that would be fine, just fine. But then I only want to see that thing over here in this section. So what I need to do is I need to get rid of the piece of the line that's not in that section. So I get rid of the rest of this line. All right. And then I look at the next guy. When x is greater than the -1 but less than or equal to 4, that's this middle section right here. And in that middle section, I just want to graph that second function, which is y equals 5. Well, that's the equation of a horizontal line, so I go up to +5, and I draw a horizontal line. And again, if I graphed the whole thing, it would look like this, and that would be fine and dandy, except I only want it in the middle section, so I need to erase the stuff that's not in the middle section. And then when I look over here at the -1, there's no equal to symbol, so I use an open dot. Back here at the -1. At the +4, there's an equal to symbol, so I use a closed dot. All right. And then the last piece of this thing, when x is greater than 4, is this last section over here, and I'm going to be graphing the function y equals a -2x. So once again, that has a y-intercept of 0 and a slope of -2, so I can start plotting this slope of -2 here. I would keep going, and when I graph this thing, yeah, I could graph the whole thing, but I don't want the whole thing. I only want that in this section over here. That's the thing I need to keep in mind. So I need to erase the rest of this thing. So I erase it here, and I erase it here. I only keep it over here, and there's no equal to condition here, so I want to use an open dot when I hit this line. Okay, and that's a piecewise function. We're graphing pieces of each of these functions on specified intervals. Okay? Number 23, I told you to skip. We're not going to do one like that. Number 24, we want to solve for x. And anytime I have fractions like this, I want to get rid of the fractions by multiplying through by the common denominator. All right, so since these all have a common denominator of 12, I'm going to multiply each side by 12. Over here, I have to distribute. And watch the magic that happens here. 12 times 2/3, it's like divided by 3, which is 4, and then times 2. That's an 8x. This is going to give me a -9 equals 1. All the fractions are gone, and now this is a really easy equation to solve. I add the 9 to each side, and I divide by the 8. So I find out pretty easily once I get rid of those fractions that x equals, that's going to reduce to a 5/4. Okay? In this next one, we want to solve this equation for y. And the tricky part about this is we don't have other numbers in here. It's all variables. So as we solve this, we follow the same process that we normally do when solving an equation. The only difference is we have to leave everything in terms of the operations because we can't actually simplify. All right. So for this one, I'm dividing by the 2 in order to get rid of dividing by 2, I have to multiply each side by 2. So I'm going to start by multiplying each side by 2. So over here, these 2's cancel. So I end up with 2a equals x plus y. And now to get y by itself, since I'm adding something to the y value, I have to subtract that thing. So I'm going to subtract this x value from each side. And so I find out that y equals, well, I've got 2a minus x, and that's it. So again, we follow the same process, but we leave it in terms of the operations, in terms of that multiplication, in terms of that subtraction. Okay? If I take a look at the next one, absolute value equations, what we do here is we first have to isolate the absolute value, so I'm going to subtract the 3 from each side. So it's going to give me a 4 times the absolute value of 2x minus 1 equals 21. And then from here, I can divide each side by the 4. If you go ahead and split this up from here, that would be fine also, because that multiplication is not going to affect anything. But if I have this, the absolute value of 2x minus 1 equals 21/4. Now the absolute value is truly by itself. So now I'll split this into 2 equations. Let me move some of this off to the side here. So now I'm going to split this into 2 equations. So the first equation is going to be the 2x minus 1 equals the 21/4. And the second equation is going to be the 2x minus 1 equals a negative 21/4. And now I have to solve each of these. And really the first step that I'm going to do in solving each of these is I'm going to get rid of that fraction by multiplying each side by 4. So over here, that's going to give me an 8x minus 4 equals 21. And then I can finish solving this by adding the 4 to each side. And then dividing by the 8. So I find out that x equals a 25/8. And then I got to do the same thing over here. Once again, I'm going to multiply each side by 4. And I do that just to get rid of the fraction because it's so much easier to deal with these things without fractions. So I get the 8x minus 4 equals a negative 21. And then from here, I just have to follow the same process I did before. I'm going to add the 4 to each side. So I find out that 8x equals a negative 17, and then I divide each side by 8. Then the last piece of this thing is just plugging it in to see if it works, and that's really the tricky part with this one because of the fractions. So if you need to take it off to the side and actually show plugging these things in, that's fine. You can do that. But when we plug this one in, both of these should work. Okay, and that's it. So plug them each in, make sure they work, and these ones should. Okay. If I take a look at the next one, with this one, again, I want to isolate the absolute value, so I'm going to divide each side by the 5. So I'm going to get this absolute value by itself, so I'm going to have the absolute value of x plus 2 equals, that's going to be a 4/5 x minus 2/5. And then from here, I have to split this into 2 equations. So I'm going to do one equation that just says x plus 2 equals 4/5 x minus 2/5. And then I have to do the opposite of that. So I'm going to do the x plus 2 equals a negative 4/5 x plus 2/5. Okay, so I'm doing the opposite, which is the opposite of each of those things. Now I'm going to solve each of these equations. Well, the first thing I'm going to do is I'm going to get rid of these fractions by multiplying each side by 5. When I do that, that's going to give me a 5x plus 10 equals a 4x minus 2. And now I'm going to get the x's on the same side, so I'm going to subtract this 4x from each side. So I've got x plus 10 equals a negative 2. And now I just have to subtract this 10 from each side. So I subtract this 10 and I find out, let's see here, that x equals, this time this gives me an x equals a negative 12. And then from here I just need to check this other one. That's a pretty ugly looking 12. Let me try that again. Okay, so now I just have to solve the other piece of this thing. Remember, I have this other half of the equation over here. I'm going to multiply each side by 5 again. Again, I want to get rid of these fractions. Don't deal with fractions if you don't have to. So that's going to give me a 5x plus 10. This is going to give me a negative 4x and a plus 2. And once again, I got to get everything on the same side. I'm going to start with the x's. I'm going to add that 4x to each side. So over here I end up with a 9x plus 10. Over here I end up with a 2. And now I finish solving. I'm going to subtract the 10 from each side. So I get 9x equals a negative 8. And then divide each side by the 9. So for my second answer, let me write it right underneath this other one, I get x equals a negative 8/9. And then, of course, the last thing I need to do, once again, I need to plug these in and make sure they work. And what happens is I start to plug these in, I'm going to find out that neither one of these works. When I plug the negative 12 in, it doesn't work. It doesn't give me a correct solution. When I plug in the negative 8/9, it doesn't work. So I don't get either of these to work, which means this one is actually no solution. Okay? If I look at the next one, I'm going to split this into two inequalities. So I'm going to do the 4x plus 1 is greater than or equal to the 9. And that's exactly the way this thing is written. But then I also have to do 4x plus 1 is less than or equal to the negative 9. And I'm going to solve each. And since the absolute value was greater than, I know this is going to be an or inequality. Remember, great or, less than. So I slap that word or in between there. And I'm just going to solve this thing. So here I subtract the 1 from each side. So I've got 4x is greater than or equal to an 8. I divide each side by the 2, or sorry, by the 4, and it gives me a 2. Over here, I've got to subtract the 1 from each side. That's going to leave me with a 4x is less than or equal to a negative 10. I divide each side by the 4, and I find out that x is less than or equal to a negative 5/2. Okay, and I slap that word or in between. Then the last thing I do, I've got to check this on a graph because I will get things that affect the solution. With an or inequality, I'm looking for maybe I just use one of these, or maybe I have something like all real numbers instead. So I want to make sure that this looks like what an or inequality is supposed to look like, two pieces open in different directions. And so for the first piece, greater than or equal to the 2, it's going to be a closed dot here and everything to this side. And less than or equal to the negative 5/2, it's going to go this way. And then from there, I look at this thing and say, all right, that's my typical or inequality, so that means my solution is correct. Okay, it works. With the next one, I do the same thing. I'm going to split it up, so I'm going to do the 3x minus 1 is less than or equal to 9, but I'm also going to do the 3x minus 1 is greater than or equal to the negative 9. And since this was less than, well, I'm going to slap the word and in between here. This is an and inequality. And now I just have to solve each. You can either distribute here, maybe I'll do it two different ways here. The two ways that you can solve this particular example, you can distribute. That's the way most folks are going to do it. That's going to give you a 3x minus 3. And then from here, we're going to add the 3 to each side. And then we're going to divide by that 3. So I'm going to have x is less than or equal to 4. I actually dropped my less than or equal to sign in that last piece. And then the other way to solve this, instead of distributing, you could divide each side by the 3 that's on the outside and go this route. Either one is really fine. That gives me a negative 3, and then I'm going to add that 1 to each side. So that leaves me with an x, an x is greater than or equal to a negative 2. And since this is supposed to be an and, I need to check it to make sure this acts like an and. So I've got the negative 2, I've got the positive 4. If I want to be less than or equal to the 4, that's going this way. Greater than or equal to the negative 2 is going this way. So I can see that they're going to overlap in between. So I get a graph that looks like this, because with the and I only graph the overlap. And also I rewrite this thing this way, negative 2 is less than or equal to x, less than or equal to 4. All right, and since I got a proper graph here, really I'm checking to see if this thing's possibly no solution. That's why I have to draw the graph. I need overlap here, and then I rewrite my answer in the proper format. Okay.